Hi, today is Monday, August 3rd, 2026. This article is from independent.co.kr, the famous news magazine from none other than the UK. Strange, never before seen material found at Hiroshima atomic bombing site. Discovery offers unprecedented insights into how matter behaves under extreme conditions. Vishwam Sankaran, Thursday, 30th July 2026. Nearly 81 years after the cataclysmic atomic bombing of Japan that instantly killed over 70,000 people, scientists have discovered a bizarre and previously unknown material from the beach sands of the Hiroshima Bay again. Many Koreans also died in Hiroshima because they lived there, right? Some were there to study, some were forced to do some labor there, and some maybe, I don't know, hold away from their home in Korea to do some work in Hiroshima, right? That's a sad story. Nuclear explosions, meteorite impacts, and other high-energy events can act as natural laboratories for America for the formation of previously unknown materials. In the study, scientists analyzed particles called hiroshimites, which are tiny spherical fragments of molten debris formed during the Hiroshima bombing when the atomic explosion generated temperatures exceeding 7,000 degrees Celsius within seconds. These hiroshimite particles were embedded in resin, polished, and analyzed under reflected light microscopes. Why was it they were embedded in resin? I do not know. We report the discovery of a previously unknown alloy preserved within a hiroshimite spherule recovered from beach sands of Hiroshima Bay. Formed during the 6th August 1945 atomic airburst, they wrote in the journal Science Advances. The particles were also examined more deeply with a scanning electron microscopy. Prefectural Industry Promotion Building after the bombing of Hiroshima. Microscopy. The researchers found unique materials formed as the atomic explosions heat vaporized building materials, metals, soil, glass, and water in a turbulent fireball that rose into the atmosphere before rapidly cooling. Vapors from the burning materials condensed rapidly into microscopic droplets that eventually settled onto the surrounding landscape. Many of these particles still remain in the sands of Hiroshima Bay after 8 decades since the atomic explosion. Previous research suggested that such particles from atomic explosions were made mainly of calcium, aluminum, silicon glasses that formed at temperatures above roughly 1,800 degrees Celsius. Now, scientists have found a new class of hiroshimite materials that form at a much higher human-made high temperature range. Researchers found that these particles contained small droplets of iron-rich alloys, including iron chromium alloys with varying amounts of nickel, manganese, and molybdenum, right? Molybdenum. The alloys, we Koreans say molybdenum, but molybdenum. The alloys were only about 3% of the overall glassy spheres and were present as tiny rounded droplets, irregular grains, or clustered inclusions spread throughout the spheres. This strange mix of elements in the spheres represents a snapshot of local metals that were present at the Hiroshima Bay area the instant the explosion happened. Researchers say one particularly unusual particle stood out, they say. This tiny grain of hiroshimite contained far more silicon than the surrounding iron chromium alloys. Scientists found it was uniform throughout its interior, with about 63% iron, 15% chromium, 9% nickel, and 7% silicon. It likely crystallized from a single molten droplet before cooling rapidly, researchers say. Such uniform crystals are not expected to form under ordinary conditions, they say. The discovery offers unprecedented insights into how matter behaves under some of the most extreme temperatures and pressures created on Earth, and may lead to new classes of materials under these conditions. Unprecedented, right? Scientists found it was uniform throughout its interior, with about 63% iron, 15% chromium, 9% nickel, and 7% silicon. It likely crystallized from a single molten droplet before cooling rapidly, researchers say. Such uniform crystals are not expected to form under ordinary conditions, they say. The alloys were only about 3% of the overall glassy spheres and were present as tiny rounded droplets, irregular grains, or clustered inclusions spread throughout the spheres. Well, it's a good article for metallurgists, but to me it's just, yeah, I studied mechanical engineering and I studied material science, so I guess this is not applicable to applied science or engineering, but it's a good find that crystals, some strange regular crystals inside some irregularly shaped droplet, can be created in the explosion of nuclear bombing, right? Well, that's it. Have a great Monday wherever you are, and have fun. Bye bye.